Thank you.
Thank you.
So this conference is about crypto, and if crypto is to change the world, it's pretty evident it should be connected to the real world. And our team will tell you how crypto is connected to the real world in Byteball platform. A short overview about Byteball. It was launched on Christmas Day of 2016. It is not a blockchain. It is based on a directed acyclic graph, DAG. It is incredibly easy to use for everybody. It features user-readable smart contracts that are very easy to interpret. And it has many bridges to the real world. Briefly about the technology. Byteball is based on directed acyclic graph, where transactions are connected directly to each other in the same way that blocks are connected to each other in blockchains. So there is only one fundamental entity in this design. There are no blocks, only transactions, no blocks, no block size, no block size issue, no block producers. And how is it different from blockchains? The key differences. First, the access to the ledger. In blockchains, when you submit a transaction, you have to go through block producers. And block producers, they look at your transactions, and decide whether to include it in the block or not. So they have the power to include or not include your transaction in the next block. In DAG, you have direct access to the ledger. You just add it to the end of the ledger, no questions asked. In terms of consensus algorithm, in blockchains, it is the block producers, again, who decide about the order of transactions. They have this power. In a DAG, it is different. There are no block producers. There are no privileged class of users who would decide. Every user on the network has to decide it for themselves, and they have to arrive at the same decision, and they do it by running a so-called reality test, which is based on witnesses. What they do, they look back in history, trying to find real known users on the DAG, and the branch of the DAG where they find those users are called witnesses. This branch is deemed real, and any other branch that might exist is deemed fake. So this is the way they decide about the order of transactions. They see the same state of the DAG. They run the same algorithm, trying to find those known users called witnesses, and they arrive at the same result, which is the consensus. Next, the security of blockchains versus directed acyclic graph in Byteball. In blockchains, the security of the blockchain as a whole is based on internal economy. The block producers are incentivized by block rewards, which are denominated in the native currency of the blockchain, and the security of this design inevitably depends on the size of internal economy. If the economy is small, well, so is the security. In Byteball, the security is based on stakes that witnesses have in the real world. They have staked their reputations, their business, and the security it rests on the real world, on the outside world, outside relative to the ledger itself. Unlike blockchains, where all transactions have to be chained one after another and have to go along one lane, in DAG, we have better capability to adapt to changing demand on transactions. And when we need more transactions, the DAG becomes wider to accommodate more traffic. And when there is less demand, the DAG becomes narrower. So it adapts flexibly to the demands of the economy that it serves. This is about scalability, and this adaptation to the increasing demand is about there are two sides of scalability: supply and demand. And as I said, in the DAG, we can put more transactions per second because the DAG can get wider. And this is about the supply side of scalability. But there is also the demand side, which is why should users use this crypto platform and how easy it is to use them. So next, Steve will tell about the ease of use that we have in Byteball.
Thank you, Tony. And one more thing I would like to add to the technology is that it really reduces cost of transaction. I mean, if you go and if you start doing transactions with your Bitcoins, on average, you might be paying $75 to $150. Here, if you'll make a transaction, $5,000, for example, recently I made, the cost of transaction was 30 of a penny. So you can imagine that if you're going to go into micropayments or if you're going to go in really small payments, it's not going to hurt you to pay. So where the cost of transaction in blockchain, traditional blockchain, is usually very high. So we, by using this technology, we avoided that. So at the heart of the user interface sits the wallet. Everybody, you know, every platform's got a wallet. And when creating this wallet, we realized that we want to make it very simple, very user-friendly, and yet very powerful. So we created chatbots as the major form of for apps, where users can interact with the merchant. For example, here you can see that the user is ordering pizza. So this chatbot is connected to the wallet. It's actually inside the wallet, and the person can pay for the services just by clicking send the money. So and the service will be delivered after that. Bot Store lays at the foundation. It's a sort of Apple Store where you can place your service and the user will see it in the list, and they can add functionality. By adding, that means the actual wallet will be added to this function. And as well as the merchants can display their application in front of the users. So if that would be interesting for them, they can immediately proceed to that without downloading anything extra. Another interesting thing we made is DAG-coin. At this point of time, if you want to send a crypto to somebody you know, you would ask them to go and download the wallet. So you're sort of limited to who you can pay the money, I mean the crypto. In our case, we realized that we should kind of destroy this barrier. And if you know somebody, and if you know this person's email or messenger, you basically can send the money to this messenger or to the wallet. That how it's going to look like. The person just clicks the link and downloads the wallet automatically and then claims the money. So you can send to somebody who is not familiar with the crypto world, but it will be easy for them to accept this money and then start using the wallet. But that was about unconditional payments, and I will ask Tony to continue and to tell us about the conditional payments. You heard about smart contracts. So when we made them completely different from what you just saw. We made them more human. We made them that way that anybody can put together the smart contract. And Tony will give you more details. Thank you.
Thank you, Steve. So this was about just plain unconditional payment. Yes, it is very easy to use them, but we should also know why should we use this feature. Unconditional payments is just user A sends money to user B, and that's all. No conditions attached. It's like a donation. But in crypto, we can attach conditions to the payments by saying that user A sends money to user B, but user B should do something in return to user A. This is a conditional payment, or in fact it is a contract, a smart contract. A smart contract is just a regular legal contract where the conditions, or the terms and conditions of the contract are written on the distributed ledger. They are machine readable, so that every peer, every node on the network can automatically and at no cost, at almost no cost, verify that all the conditions of the terms and conditions of the contract were met. If this is the case, the contracts can be enforced, effectively enforced, which means certainty for all the parties that make those contracts, which means, as a whole, this is a safe environment where contracts can be created and enforced. And in a safe environment, encourages creation of value. The smart contracts were covered extensively in the previous talk, and there was a lot of discussion about the conflict between the intent and the implementation of a specification of a smart contract. Byteball goes one step further to be more accessible to users. In Byteball, smart contracts are written in very simple declarative language, which can be viewed in human-readable form. And this language just says the conditions when every party can spend the money locked on the contract. And these contracts are very easy to understand for every user. User doesn't need to be a developer and doesn't need to trust a developer. So it is like smart contracts for everybody, smart contracts for people. Let's consider one simple example, flight delay insurance. For example, we want to make a contract which is an insurance against flight delay. There are two parties, the insurer and the insured. For example, the insured pays 10% of the total to the smart contract, and the insurer pays 90%. And the contract says that it can be unlocked by the insured if the flight is delayed by more than 1 hour, or by the insurer otherwise. And to know the actual delay of this flight, there is an oracle referenced in the smart contract, which is a trusted data provider, trusted by both parties. It is trusted to provide accurate data about the real delay of this flight. It is not a party of the contract. It is just a data provider who doesn't need to know anything about this contract. And its function is to import the data from the real world into the ledger. So this contract is written in an easily readable language, which can be represented in human readable form, this is how the party that accepts the contract sees it. And the party which composes the contract has a special tool which is built in the wallet. The party doesn't need to be a developer. It is not some programming language. The contract is composed right in the wallet. So the nice thing about these smart contracts is that they are verified by multiple independent peers who all check the terms and conditions of the contract and make sure that it executes exactly as agreed upon by the parties. The other party, it is not possible that the other party doesn't pay or doesn't deliver. So what makes smart contract enforcement special is that for parties who participate in the smart contract, no reputation is required because trust is ensured by the distributed ledger. No real names are required. Enforcement is automatic, inexpensive, fast, and P2P friendly. All this means that there are incredibly low barriers to entry if users want to make contracts with each other. They don't need to rely on other enforcement mechanisms such as the law, reputations, which are expensive and not quite certain. In smart contract world, this is certain, and there are very low barriers to entry, very low cost. This is about enforcement of smart contracts. There is other link to the real world that Byteball has as a platform for investments, and Eli will talk about this connection to the real world.
Thank you. Okay, so the first connection is obviously KYC, which is also part of the heart of Byteball. It's embedded in the platform. The second part is sovereign identity, which is a unique feature which allows you to actually choose which part of your identity you disclose. Coming up is attestation of accredited investor status, which we will introduce a little bit later on. And this is the roadmap, which you're also welcome to ask any of us about today. I don't know, should we repeat what you've said, or? Yeah.
Thank you, Larry. So this is a common feature that we are going to release soon. For investments, you need to know, to sell security tokens, you need to know that your investors are accredited investors, you have to limit sometimes access to your tokens to only accredited investors, and we're going to have this kind of attestation too. So this is about our connections of Byteball platform to the real world, and this is how we. This is our journey to where we are now. The platform was launched on Christmas Day of 2016. In March, we launched conditional payments, which is a simple smart contract, which allows to send one token and ensure that in exchange you receive another token, for example, or make a payment which is bound to a condition which is posted, which is confirmed by an oracle. In April, we launched prediction markets, which is a smart contract that allows two parties to pay their shares to a smart contract, and the party which correctly predicted the outcome receives all the money locked on this smart contract. Again, in April, we launched P2P flight delay insurance, which is, in fact, a special case of prediction market. We already considered it a few minutes ago. In June, we launched a bot store, a platform for distribution of applications. In July, we launched flight insurance bot, which allowed to sell insurance contracts very easily and very fast. A little bit later, in August, independent developers started to creating applications for the bot store, and in August, 2 black bytes exchanges were launched by independent developers. In September, a betting bot was added, also developed by an independent developer. In October, we launched manual oracles, which allowed everybody to run a prediction market without any technical skill, just by using the wallet. In November, we launched ICO bot, which allowed teams to raise money. Again, right in the wallet and very easy chat interface. In December, we introduced TextCoin, which Steve talked about, which allowed to send money over email and over chat messages. And in January, we launched attestation of real name, a tool for KYC, a tool for applications that require real name identity. So this is about the connections of Byteball to the real world, and this is not some ambitious plans. This is what already exists on Byteball platform, what already works. It just works on this platform. Thank you.
You have still 10 minutes.
Good. Questions?
Yeah.
This is a short question. The technology that you're using, the DAG one, it reminds me a bit of the IOTA technology. Is this the same, or what are the differences?
Well, yes. Both IOTA and Byteball are based on DAG. Essentially, this is where the similarities end. All the rest is different. In IOTA, you can just send plain payments from one party to another party. In Byteball, you have smart contracts, attestations, KYC, so on and so on. And the target markets are also different. IOTA targets machine-to-machine communications. Byteball targets regular users, That's why ease of use. That's why the crypto features such as smart contracts are made incredibly easy for end users, for everybody to use.
Two questions. One is why the name? What's the story with the name? I think it's a cool name. Second question, accredited investors. It's not quite clear in Europe, it's sometimes confusing what an accredited investor would be. So how are you going to solve this? You know, I wouldn't want to be a person to decipher German BaFin rules for accredited investors, so how are you going to solve that problem? And in the US, there are accredited investor services already existing. Are you going to link to some of them?
Okay, yes, about the first question. Why Byteball? Byteball is based on DAG, in which once you add a transaction, other users can add transactions that reference your transactions. Then these are called child transactions relative to yours. Then other transactions, other users can add more transactions on top of child transactions. So the number of other transactions that reference your transactions grows like snowball. That's why the ball in Byteball. And Byte is the name of the native currency of Byteball. It is the currency that is used to pay fees. And the fee is based on the size of data that you add to the ledger. If you add 1 kilobyte of data, you pay 1 kilobyte of currency. So that's why Byteball. About accredited investors, the tool that we are doing right now is for US accredited investors. And we're going to use a third-party provider, maybe somebody of you know about it. It is verifyinvestor.com, which will verify the investors for us and tell us the result, and we'll post just an attestation that this Byteball address belongs to an accredited investor, accredited according to the US law. Well, in all other countries, there are similar laws about access to risky investments. In Europe, they're usually called qualified investors. It is essentially the same. Down the road, we're going to check investor status maybe in other countries. So it is also possible to make many more attestations. And one investor can be accredited as a US accredited investor, attested as a US accredited investor, and there will be another attestation for German qualified investor, for example.
Okay, thank
you. You said in your presentation how you can do, for example, conditional payments and smart contracts, that it's very easy to do it. And like in the presentation just before, we saw that it's extremely complicated and dangerous to do those smart contracts on Ethereum. How did you overcome these problems? Why Byteball just works while everybody else has these huge problems, for example, with the smart contracts, but also IOTA with the Tangle? Why does Byteball just work? And it's even easy to work with Byteball.
Well, it is initially the purpose of Byteball to be accessible to the widest audience. That's why we chose to code smart contracts in a very simple language, which is very easy to interpret. But it is not Turing complete. It is not as powerful as Ethereum's Solidity. You can't code anything. You can code only some essentially very many use cases which are used in many contracts that we deal with in everyday life. But this limitation of the language allows to make it allows to make it easier to use, to be able to show the contract in a user-readable form that every user can read like a regular contract.
Just one more short question. From what I understand, a DAG works best when it's big, when there is enough transactions aligned. It makes it safer. So, in what state are you at the moment? Can you consider your distributed ledger to be safe and stable, or is it something that you're going to achieve in some time as you grow?
Well, it is as safe as the security of Byteball consensus algorithm depends on the trust on real users, which are called witnesses. That is why the safety of all transactions on Byteball depends on real trustworthiness of those users. So it is very important to choose the right witnesses. At the moment, it is a bit centralized because all witnesses are controlled only by me. So it is a single point of failure. It's not right in crypto. But over time, we want to distribute these witnesses to well-known, reputable companies, individuals, and so on. So the security will depend on honesty of those users.
Could you add some more detail on sovereign identity?
Yes. Sovereign identity means that the personal data is stored only with the user, only in his wallet. There is no central party that can be hacked and where private data can be stolen. The private data is stored only on the wallet and can be disclosed only when user wants to disclose, and only those fields. For example, he can disclose his date of birth, but nothing else, for a service that needs an age check. Every user decides what to disclose, what to not to every service. So the owner of the data has full control over this data. That's why sovereign identity.
So sovereign ID opens up inside another app, for example?
No, it is in the same app. The second screenshot, when you disclose your identity to somebody else, you choose among your identities. You can have several, and decide which fields you decide, which fields do you want to disclose.
And when that's stored in the user's wallet, that wallet is on the blockchain. It's not on, for example.
No, the wallet is on your computer.
It's actually.
Yes. What is on the blockchain, or rather on the ledger, is only the hash of this data, the hash of all this data, which just designed for the other party to be able to verify that this data that they receive is authentic.
It's time for the last question. If there is no more, I would like to thank you for participation in the first part of the workshop.